Scene script. Have you ever wondered how a simple design flaw can turn an engineering marvel into a wobbling wonder? Engineering and physics, two disciplines that have shaped our world, are indeed filled with enigmatic mysteries. They are the invisible hands that mold our reality, the silent architects of our daily lives. From the towering skyscrapers to the bridges that link our lands, engineering and physics turn the impossible into the possible. At the heart of these disciplines lies a principle that can be both a friend and foe. Resonance. Resonance, in its simplest form, is the phenomenon that occurs when an object vibrates at its natural frequency. In music, it's what makes a guitar string hum when it's plucked. But in the realm of engineering, it can lead to disastrous consequences. Consider the case of the Millennium Bridge in London, an engineering marvel, a testament to human ingenuity. It was supposed to be a symbol of a new era. But on its opening day, something unexpected happened. The Millennium Bridge began to wobble. On the surface, it may seem like a trivial issue. After all, bridges are meant to withstand the forces of nature, the wind, the rain, the snow. But the wobble was not a result of these external forces. It was something far more insidious. You see, every structure has a natural frequency at which it vibrates. This is usually harmless, but when the frequency of the vibrations matches the natural frequency of the structure, it leads to resonance. And resonance, when uncontrolled, can lead to catastrophic results. For the Millennium Bridge, the simple act of people walking across it was enough to set off this resonance. The bridge started to sway, matching the rhythm of the people's footsteps. What was supposed to be a symbol of progress and engineering prowess turned into a testament of a design oversight. The Millennium Bridge, once a marvel of engineering, became a wobbling wonder due to a simple design oversight. In the heart of London, a new bridge was conceived to celebrate the turn of the millennium. This was not just any ordinary bridge, this was the Millennium Bridge, a symbol of a new era, a gateway to the future. The planning and design phase of the Millennium Bridge was a testament to human ingenuity. The architects, Sir Norman Foster and partners, and the engineers, Arup, had a grand vision. They aimed to create a bridge that was not only functional but also a piece of art. They wanted to design a bridge that was unique, unlike any other in the world. The design was indeed unique. The Millennium Bridge was a suspension bridge, but not in the traditional sense. Instead of using vertical suspensions, the tension was held by lateral cables, giving the bridge its distinctive shallow profile. This innovative design won the hearts of many, leading to its selection from over 200 entries in a competition organized by Southwark Council. Now, let's take a moment to appreciate the sheer magnitude of this project. The Millennium Bridge spans over the River Thames, linking Bankside with the city. It is a pedestrian-only steel suspension bridge stretching a total of 328 meters in length and 4 meters in width. But this bridge was more than just an engineering marvel. It was a symbol, a tribute to the new millennium. It was a statement that said, "We are ready for the future." The Millennium Bridge was a testament to the human spirit, to our ability to dream and to create. However, in all its grandeur and glory, there was one crucial element that the designers overlooked, an element so fundamental, it threatened the very essence of their creation. And that was the dynamic interaction between the bridge and the pedestrians. Little did the designers know, their engineering marvel would soon turn into a mystery. The Millennium Bridge, in all its glory, was about to become a puzzle that would baffle engineers and physicists alike. On its opening day, the Millennium Bridge, instead of standing firm, started to sway. It was the 10th of June, 2000, a day that should have been a celebration of engineering prowess, but instead, it turned into a day of confusion and panic. The London Millennium Bridge, the first pedestrian river crossing over the River Thames in central London in over a century, was swaying alarmingly. As the first eager pedestrians stepped onto the bridge, they felt the structure move beneath their feet. This wasn't the gentle vibration one might expect from a heavily trafficked bridge. No, this was a distinct rhythmic sway, a side-to-side motion that made crossing the bridge a dizzying, unpleasant experience. The bridge was designed to handle a load of 5,000 people at once. However, even with fewer than that number, the bridge began to sway unexpectedly. The pedestrians, surprised and alarmed, clung to the handrails, their joyous celebration turning into a harrowing ordeal. The swaying was so severe that authorities had to close the bridge only 2 days after its grand opening. It was a humbling moment for the engineers who had designed and built it. The Millennium Bridge, hailed as a symbol of the new millennium, a monument to human ingenuity and engineering skill, had become a public spectacle of failure. The oscillations weren't just a minor inconvenience, they were a serious safety concern. If left unchecked, the swaying could have led to structural failure and potential disaster. It was clear that the issue needed to be addressed, and quickly. What caused this unforeseen swaying? Was it a design flaw, a miscalculation, or was there a deeper, more complex reason behind it? Engineers and physicists were puzzled. They had been certain the bridge was sound. They had followed all the guidelines, carried out all the necessary tests. Yet, here was the Millennium Bridge, defying their calculations, swaying like a leaf in the wind. The swaying of the Millennium Bridge was not just a malfunction, but a mystery that baffled engineers across the globe. This was a riddle wrapped in the heart of steel and concrete, a conundrum that would take months of investigation to unravel. Engineers were puzzled, scratching their heads. What caused this engineering marvel to sway? With the pride of London's engineering at stake, an intensive investigation was launched to unravel the mystery behind the Millennium Bridge's unexpected movements. The initial hypothesis was wind-induced vibrations, a common cause of bridge sway. However, the weather on the opening day was mild, making this an unlikely culprit. This led the investigators on a deeper quest, probing into the very core of the bridge's design and structure. The breakthrough came when a team of physicists and engineers stumbled upon a rare but fascinating phenomenon: synchronous lateral excitation. Quite a mouthful, isn't it? But let's break it down. In layman's terms, synchronous lateral excitation is a fancy way of saying that when a large number of people walk in step, they can generate a significant sideways force. This force can cause a bridge to sway if it matches the bridge's natural frequency. It's like pushing a swing at just the right moment to make it go higher and higher. Now, you might be wondering, how often do crowds of people walk in perfect unison? Surprisingly, more often than you'd think. When a bridge starts to sway, even slightly, people instinctively synchronize their steps with the sway to maintain their balance. It's a natural human response. This is precisely what happened on the Millennium Bridge's opening day. The slight sway caused by the crowd's footsteps resonated with the bridge's natural frequency, setting off a feedback loop that amplified the sway. The bridge was, in essence, dancing to the rhythm of the crowd. So, the mystery was finally solved. The Millennium Bridge wasn't flawed because of poor materials or shoddy construction. It was a victim of a unique yet overlooked phenomenon. A phenomenon that turned an ordinary walk across the bridge into a synchronized dance, causing the structure to move in a way no one had anticipated. The Millennium Bridge was a victim of its own design, a casualty of an overlooked phenomenon. And that, my friends, is the fascinating tale of how physics and engineering came together to decode the mystery of the swaying Millennium Bridge. The Millennium Bridge, once a symbol of failure, rose again, stronger and steadier. The bridge that once swayed with the synchronized steps of pedestrians, causing panic and fear, now stands firm, a symbol of triumph over a significant engineering challenge. To tackle the swaying, engineers and physicists joined forces to devise a solution. They installed what's known as dampers. These devices, similar in principle to shock absorbers in cars, were designed to counteract the bridge's movement. Over 90 dampers were placed across the structure, some to address the horizontal issue, others for the vertical movements. This combination, known as a tuned mass damper system, is a classic example of how physics can solve real-world problems. Following these modifications, the bridge was put to the test again. Would it sway as before, or would it stand firm? As the first steps were taken, the tension was palpable, but this time, the bridge didn't sway. The modifications had worked. The bridge stood strong, steady, and safe. A triumph of engineering. Fast forward to today, and the Millennium Bridge is now a beloved feature of London's skyline. It welcomes thousands of pedestrians every day who cross it without a second thought to the engineering marvel beneath their feet. Its sleek modern design, combined with its historical significance, makes it a must-visit landmark. The Millennium Bridge is more than just a bridge. It's an icon of resilience, a testament to the power of science and engineering. It shows us how failure can lead to success, how challenges can lead to innovation, and how an understanding of the physical world can solve practical problems. The Millennium Bridge now stands not just as a bridge, but as a testament to the relentless pursuit of knowledge in physics and engineering. It's a reminder that in the face of adversity, human ingenuity and determination can triumph, transforming failure into success, fear into confidence, and a shaky bridge into a symbol of strength and stability.